Did you know that you have trillions of immune cells in your body? What about the fact that billions of specialized immune cells carry out their lives in your brain, changing how you think and altering how you feel? Our immune system is one of the most spectacular defense mechanisms we have, but when things go wrong, it can be absolutely devastating to our health and especially to our brain health. In today's episode, we're exploring the most common way that immunity can go wrong, which we often call inflammation. Specifically, we'll dive into what inflammation is, why when left unchecked, it's so devastating to brain health, and most importantly, what you can do today to fight the effects of inflammation in your brain and in your body. I am Dr. Austin Perlmutter, and this is the Better Brain Blueprint.
Having a healthier brain feels empowering.
Limitless.
Inspiring.
It feels peaceful and it feels hopeful.
It is so essential to your health.
Your brain is your greatest asset.
Improve your brain.
Improve your brain.
Improve your brain.
Improve your life.
Improve your life.
There is no alternative.
Live better longer.
You deserve that.
In this episode, we'll be covering powerful, life-changing information. Remember, if you want full access to the Better Brain Blueprint now and for years to come, you can invest in the entire series, along with the exclusive bonus materials right now for a special price that is only available during this broadcast. Don't wait. Your brain will thank you. Inflammation is often discussed in its relationship to disease. That's because chronic inflammation is a major risk factor for the most common causes of death and disability around the world. But most of the time we're thinking about inflammation in the body, it's the achy, swollen joint. It's the itchy bug bite on our arm. But what does inflammation look like and feel like when it's in the brain? Research over the last decades has convincingly shown us that when excess chronic inflammation happens in the brain, it can contribute to a host of issues. In fact, having too much inflammation for too long in the brain is thought to be a driver of everything from depression to dementia. It's been linked to autoimmune diseases like multiple sclerosis and even to PTSD. To begin, I think it's important for us to define inflammation. Technically speaking, inflammation is a complex biological process of the immune system. Even though inflammation gets a bad rap, it's actually a vital part of what keeps us alive. And so here's how it works. When our bodies are exposed to harmful stimuli in the form of injuries and especially potential infections, our immune system revs into action. Immune cells located near the site of damage or in our organs and in our bloodstream have specialized receptors that listen, that sense for evidence of damage or for harmful bacteria and viruses. When those receptors are activated, the process of inflammation is set into action. This looks like increased dilation and permeability of our blood vessels, recruitment of more immune cells, and production of a host of molecules that can help to neutralize the threat. Again, this process, it's absolutely essential to life because without it, we would quickly succumb to even the most trivial infections. But while short bursts of inflammation can be helpful, there are major problems that occur when inflammation gets left on for too long, even if it's at a very low level. This type of inflammation, often described as chronic inflammation, has been the most strongly linked to all manner of diseases and especially brain diseases.
Inflammation actually comes from Latin inflammare, which means to light on fire. And in a very real sense, this process of inflammation is lighting the brain on fire. It's burning the brain. And anything we do that increases inflammation in the human body is going to be threatening to the brain.
What's happening to us today is our diets are basically alarm foods. They're high in salt, sugar, and fat. They deliver quick calories in massive amounts without proper support with other nutrients that are necessary for their orchestration. And they're eaten in environments that are at best rushed and at worst hostile. And the outcomes are alarm. And so the diseases we have today are diseases of inflammation. Inflammation is our body's response to being at risk. And we are running lives of feeling like we're at risk. So I think it's interesting to note part of this story of nutrition starts way before we ever eat or select what we're going to eat. It relates to a question that we should be asking ourselves, something like, are we worthy and deserve to be in good health?
It's really important to understand how do we address inflammation in our bodies and in our, in our society. And I often joke that functional medicine doctors are inflammologists. That's part of what we do, is that we understand how to investigate inflammation, which most of us never learned how to do in medical school, other than, oh, you have an infection or you have a fever or you have an autoimmune disease or whatever. But we don't really know how to think about ferreting out the root causes of inflammation, which is critical if you're going to cure some of these problems or prevent them.
Inflammation is a downstream consequence of having a higher blood sugar, a downstream consequence of the foods that we eat. When the brain is inflamed, it sets into motion these what we call feed-forward cascades, meaning that more inflammation in the brain changes how certain cells in the brain work. We call these cells microglial cells. And when they change their functionality, what do? They increase inflammation.
As we've discussed, chronic smoldering inflammation is a real threat to human health and especially to brain health. So what is driving this specific type of inflammation? Are there choices that we make each day that can either increase or decrease this risk factor for disease? The science is showing us that the answer is a resounding yes. Poor diet, lack of exercise, bad quality sleep, and too much stress have all been linked to higher levels of inflammation. In fact, it seems to be the case that many of the things that we now see as normal may actually be driving chronic inflammation in our bodies and in our brains. Let's dive into what in our modern world is leading to chronic inflammation, especially as it relates to the food that we eat.
We can increase inflammation clearly by the dietary choices that we make. Diets that are involved in more refined carbohydrates, ultra-processed foods, that's for sure, higher in sugars, and deprive our bodies of things like dietary fiber will immediately increase the risk of bumping up inflammation, threatening the gut integrity such that chemicals get across the gut wall and turn on our immune cells to make these inflammatory chemicals. And guess what? They go right to the brain. That's a bad scenario, bad situation.
So we talk about omega-6 fats, saturated fats, omega-9 fats, which is oleic acid from olive oil, omega-3 fats, and often people think about it as fish-related oils. All of those different families of fats have very different influences on brain chemistry. We know, for instance, that one of the saturated fats, which is common in very high feedlot-fed animal meat diets, because of the way we feed animals in the feedlot, this fatty acid that's a saturated fat is known to be a pro-inflammatory fat for brain chemistry. So if you eat a lot of food that contains that particular type of fat, it may increase your risk to brain inflammation. So that's the fat story. Now, those are probably fairly well known. And then we throw into that the vitamins and minerals, and we know that many of the vitamins play very important roles in brain chemistry, particularly the B complex vitamins, thiamine, riboflavin, pyridoxine, cobalamin, which is vitamin B12, folic acid. And we started to recognize that these regulators of the blood-brain barrier, the ports or the gates, the channels, could be relaxed, and that they could be not functioning entirely well, so that you could have, to use a euphemistic term, a leaky brain. So these gates of entry in a leaky brain could be reasonably large in terms of their ability to accommodate the passage of molecules. So if you put together the two things, that the brain has an immune system in the microglia, and that the blood-brain barrier isn't entirely capable of eliminating all new molecules that might cross into the brain, which could have immunoreactivity, and that these microglial cells have receptors on them that could pick up information from molecules to, like the macrophages of the body, circulating the blood system, could respond in a reactive immunological way that could then induce in neurons a companion response, an alarm response that would produce then inflammatory molecules like cytokines.
We have cells that are called microglial cells. Microglial cells are extremely important because they're sort of like a jack of all trades. I mean, they react to things immunologically and cause inflammation. So let's just say, for example, you get meningitis, which is an inflammation of the meninges, which cover your brain and your spinal cord. They are going to flare up because they know that there's a bacteria or a virus and they're going to work to kill them. So you're going to have that inflammation. It's acute. It should go away. So that's great. But they also clean things up, right? They help clean up the mess of, let's just say we have toxins that we're eating or we're smoking or drinking, or they're repairing the brain. They're really important for repair and, phagocytosis or cleaning up debris. They really do a lot of things. Now, think about it though. If we are constantly sort of giving our brain, toxins and stressors and lack of sleep and all this kind of stuff, they're going to be overwhelmed and they're going to stay in a state of sort of constant activation or, excitation. So they're excited. And that over time actually damages your brain. So, one of the thoughts is that there is a problem with the blood-brain barrier issue. There's an increase in these stressors and toxicants that are being delivered to the brain, also coupled with poor sleep and low nutrient status that is not feeding the brain what it needs in order to repair and get rid of free radicals. And so what happens over time, we get just a lot of neuroinflammation, and neuroinflammation is going to, definitely damage brain tissue, interfere with neurotransmitter production. Just really, it's really sort of a disaster. So I think that's why we're seeing more of that lately.
The gut plays this central role in inflammation, in immune dysregulation. I think this is the real plague of modern life, is immune dysregulation. And we at this point have immune systems that are poorly calibrated. They underreact to formidable pathogens, as in the case of chronic Epstein-Barr virus or even long COVID, arguably. We overreact to benign stimuli in the case of seasonal allergies, and we attack our own self-tissue in the case of autoimmune disease. I think a lot of this has to do with what's going wrong in the gut in modern life.
93.2% of Americans are metabolically unhealthy, means they're somewhere in the spectrum of prediabetes or type 2 diabetes. And they basically start getting visceral fat and belly fat that produce inflammation. And that leads to systemic insulin resistance in the brain. And you end up with this cognitive decline that results from basically our modern processed, highly refined sugar and starch diet. Essentially, you get a type of insulin resistance in the brain and you get increased glucose, and you end up with more what we call advanced glycation end products, or AGEs, which are inflammatory molecules that then bind to receptors called RAGEs, which are receptors for these advanced glycation end products. And it's basically proteins and sugars climbing together and forming like a creme brulee kind of crusty thing. And that can happen in your brain. And that ends up creating an inflammatory cascade. It activates all the glial cells, which is the brain's immune system. And it ends up creating this cascade of inflammation that is driving most of the decline in our brain. And by the way, we're talking about Alzheimer's here, but it turns out that almost every brain disorder, whether it's autism or ADD or depression or anxiety or PTSD or Alzheimer's or whatever, is a disease of inflammation in the brain.
Bacon is the food with the highest level in many different studies of AGEs. I mean, think of bacon. It's fat that has been, crispified. It is definitely, it's got a lot of AGEs in there. It's aging you. Essentially, that's what it's doing. And sometimes people have to hear it like that yes, things like that are grilled, fried, broiled, can lead to accelerated aging processes in the body. And that would be mediated through inflammation.
Okay, we've talked a bit about what inflammation is and what's causing it, and why we definitely don't want to be experiencing chronic inflammation in our brains. Yet more important than the biology of what's going wrong here is what it's actually doing to our health. What might it feel like when we have brain inflammation? Compelling research has shown us that there may be both short-term and long-term implications. For example, when researchers take healthy participants and inject them with a part of a bacteria that reliably creates inflammation, those volunteers tended to experience a number of symptoms of depression. In the long run, low levels of brain inflammation may make it harder for us to think clearly, and they may increase the chances that we develop cognitive impairment and potentially even conditions like Alzheimer's disease. Let's explore how exactly inflammation in the body can lead to these conditions and the spectrum of brain health outcomes linked to increased chronic inflammation.
We know that there is a great predictability of brain functionality decline in people who have higher markers in their blood of inflammation, of the actual mediators of inflammation, things like something called tumor necrosis factor alpha, or a marker of inflammation called the C-reactive protein, or CRP. These markers, which are pretty standard blood tests these days, are harbingers for brain decline. They indicate inflammation, and inflammation then sets the stage for brain decline. Even a simpler test for inflammation is the blood sugar. Blood sugar is a surrogate marker for inflammation. So eating foods that raise your blood sugar over time are directly related to increasing inflammation, a powerful threat to the human brain. Inflammation in the body creates a scenario where you actually increase inflammation in the brain, and that is a bad thing. Because when these microglial cells turn on and start producing inflammation themselves, they actually enhance the production in the brain of this damaging protein called beta amyloid. They increase its production and reduce its clearance. And it all starts really with our food and other lifestyle choices, setting the stage for this process of inflammation that we can absolutely rein in by making better choices.
Leaky gut can create states of chronic systemic inflammation, which directly impact the brain. In fact, the amygdala is so central to anxiety. It's sort of our fear center in our brain. When the body is inflamed, it sends information to the amygdala that's basically saying the body's under attack. And then the amygdala amps up the feeling of, okay, everything is potentially a threat.
We should talk about the cytokine drizzle, which means while these chemicals of inflammation are not dramatically turned on right this minute, they're just a little bit elevated. But when you play that over a long period of time, it's like the Colorado River carving the Grand Canyon. Didn't happen overnight like a cytokine storm, but over time there is a huge devastation in the brain. I mentioned the incredibly increasing risk of Alzheimer's disease, increasing rates of Alzheimer's disease, incidence of brain decline. And it clearly, in my mind, my opinion, is a consequence of the multiple lifestyle factors that have changed. And I think on the top of the list has to be the sudden, immediate change in human nutrition that's happened in the blink of an eye in relationship to the amount of time that we've been walking this planet. Suddenly, we confront our genome, we confront our DNA with a set of circumstances and influences, the likes of which our DNA, our gift from all of those who have come before, have never seen before. And what happens when the DNA and then our physiology is confronted by these dramatic changes? Things are produced in the body. Things like increased production of damaging chemicals called free radicals, increased production of chemicals related to inflammation, increase the risk of insulin resistance, increase in our blood sugar. And all of these independently act to threaten the brain. That's for sure.
We actually become more tired when certain inflammatory cytokines are released. And it's probably evolutionarily so that we can rest, we can go to sleep, we can sort of let our body actually, recover from the illness. So it's a built-in side effect that you're not going to feel very well, or you're going to feel sort of tired when you're trying to recover from something.
Fundamentally, you have to look at your brain as a very energy demanding organ. And it's also very sensitive to aberrations in inflammation in the body. So when people have inflammation in the gut, they have inflammation in the body. And it's just so important for people to recognize that food intolerances, food sensitivities, poor fuel supply, poor diet that creates inflammation in the gut, it's going to be felt in the brain too.
A lot of vascular disease is caused by insulin resistance, starch and sugar, processed food, and inflammation. And so you by kind of cutting that out and actually shifting your diet more fat based as opposed to starch based and sugar based, it will help your brain. And that's what I was saying. Like in an extreme case, ketogenic diets, which is almost all fat, 70% fat, actually can have remarkable effects on the brain. We first learned this with epilepsy as a way to treat treatment resistant seizures. We now see it as a treatment for brain cancer. There's a whole metabolic theory of cancer now, which is gaining traction. I think it's fascinating. And these are like Alzheimer's, autism, Parkinson's. It's being tested and actually found to be quite effective.
As we've just discussed, inflammation in the brain is linked to a wide variety of diseases, ranging from dementia to mood disorders. But remember that too much chronic inflammation is by definition a problem with our immune system's behavior. Our immune system is a massive web of trillions of cells, and chronic inflammation is just one way that immunity can be organized. So how does inflammation map onto the larger topic of immune function? And what might that tell us about the connection with brain-related autoimmune diseases, like lupus and multiple sclerosis? We know, for example, that autoimmune diseases are thought to be inflammatory diseases, with good examples being rheumatoid arthritis, systemic lupus erythematosus, inflammatory bowel disease, and multiple sclerosis. Two of these conditions are major concerns in the brain: lupus and, of course, multiple sclerosis. Similarly, we know that a number of allergies are linked to higher levels of inflammation. This may help explain why it can be tough to think clearly when we're experiencing allergic symptoms. The bottom line here is that we're dealing with an incredibly complex biology, but at the same time, we know that there are simple steps that we can take to act on this biology to help bring our immune state, especially inflammation, towards a healthier place of balance.
So our immune system and our body's inflammatory process definitely affects the brain in multiple ways. And when we think about where our immune cells are located, yes, they are constantly going through our bloodstream and our lymphatic system. We have some that are sitting on the surface of our cells. We have a very large amount hanging out outside of the gut. And then the brain also has its sort of own little unique immune cells as well. And there is a huge connection between the bulk of our immune cells, which is say out, near the gut immune system, and the brain. So there's a gut-brain axis when it comes to our immune system. And that is probably one of the key issues as to why inflammation or inflammatory messages, cytokines, etc., are going to then be transferred or communicated to the brain and then cause problems there. Basic immune dysfunction, which almost always includes inflammation, can affect the brain. But then there's other things that can also affect the brain that, such as nutrient deficiencies and things like that, which may not necessarily be inflammatory in nature, but they're very important for our brain to work normally. So I think that when someone presents with, sort of brain fog, cognitive issues, anything that might be brain related, it's really important to look at their symptoms, when did it start, what their environment is like, because then you can sort of pick out what their specific risk factors might be. And that gives you a better sense. And then, of course, you can look at lab work, et cetera. I personally think there's always an inflammatory component when I see anyone who has any sort of brain symptoms. But of course, that could be, there could be some cases that's not true. So I'm always looking for inflammation at the source.
When I think about, for instance, how I approach someone with an autoimmune disease, I think about some of the testing that we do, like lymphocyte maps or looking at flow cytometry as an example, looking at, this complexity of the immune system. And I'm still a bit underwhelmed at where we are with laboratory testing. So I feel like we're so much further along when it comes to cardiometabolic testing than we are with things like autoimmune disease or even with depression and inflammatory profiling. I was reading one paper, kind of a systems immunology approach, and the author was talking about how the complexity of the immune system is similar to the complexity of all of the different cheeses that you can get in France. And I think that's a really an apt analogy because if you've ever traveled in France, I mean, the cheeses are just exquisite. They're so complex. There's so many of them. I mean, 400, 500 different types. And I would say the immune system is very similar. And then if we broaden this conversation, because it's not just the immune system that you and I are interested in, I think about the role of something like trauma and how that impacts the homeostasis of the body, not just the brain, but the body more globally. And we know that it has effects that are much stronger than just the psychological system. You know, I think of it in terms of the PINE system, the psychoimmunoneuroendocrine system. And so those are all the systems that we want to be tracking when it comes to something like trauma, or even someone who's sitting in front of you who's got some brain complaints.
Let's tie all this together. Our brain's immune system is made up of trillions of unique cells called microglia. Microglia are sensitive to signals they pick up from the brain and from the body. This means that our body's immunity and levels of inflammation are connected to our brains. We also know that our neurons are not just impacted by, but even participate in immunity. That means that there are so many opportunities to change our brain's immune system for the better or for the worse. We absolutely want to be giving them signals that keep them away from states like autoimmunity or chronic inflammation. So what might that look like? We'll explore that next. The Better Brain Blueprint is all about empowering you to lead a longer, better, happier, and healthier life. No matter your health history, you have the ability to improve your brain function right now by incorporating the information from this series into your daily life. This cutting-edge information just isn't available anywhere else. And that's why owning all of the expert interviews, the transcripts, and the supporting materials is so incredibly valuable. I highly recommend making the Better Brain Blueprint, along with the bonus materials, part of your family library. By making some simple lifestyle changes, you can create lasting improvements in your health and in your life. These changes may not only lower your risk for conditions like Alzheimer's and mood disorders, they will almost certainly improve your brain function right now. You might notice that you start thinking more clearly, forgetting less, and generally feeling better throughout the day. Sometimes the hardest part in taking action and making these lifestyle changes is figuring out where to start. If you're ready to start right now, the bonus materials include resources that will help you apply this knowledge to your life, one step at a time. We interviewed the world's leaders in general brain health, mood disorders, Alzheimer's disease, and more. And we received some fantastic, actionable information from each of our experts. Unfortunately, we didn't have room to include it all in this series, but we know it's critical, life-changing information that has the power to transform your health. That's why the bonus materials also include the full-length interviews from all of the experts you've seen throughout this series. The great thing about owning this series is that you can easily share it with friends and family and watch their lives change too. In fact, if you found this series helpful, I invite you to share this broadcast event with a friend or with your loved ones. You just might change their lives and their destiny. The most important investment in your life is an investment in your health. Click the button on this page to invest in your Better Brain Blueprint today. I know this episode has been filled with a lot of concerning information, but on the flip side, I'm hoping this is more than enough to convince you that you need to take the topic of inflammation seriously. Scientists have shown that this is one of the most important addressable risk factors for disease, and that definitely includes those in the brain. As our speakers have alluded to, there's lots we can do about this. So now let's jump into the empowering actionables, and let's talk about practical strategies to help reduce your brain's risk of having issues with unhealthy inflammation.
I encourage people to eat a lot of these things like curcumin and green tea and quercetin products, which you can get like Himalayan tarry buckwheat or get it from onions or apples. Glucarpharin from the broccoli family of vegetables. All these have really unique properties that regulate inflammation and regulate oxidative stress, regulate mitochondria, regulate insulin resistance. One of them that I really love is called urolithin A. It comes from pomegranate. It's what we call postbiotic, is when you eat food, your bacteria metabolize it and it turns into other things. So you get these chemicals that are produced by your bacteria. Actually, it's interesting. I was just talking to a scientist who was studying Akkermansia, finding it has GLP-1 agonist activity. So it's like a probiotic that produces a compound like Ozempic, which probably why it helps blood sugar and metabolism. So it's kind of interesting, these postbiotics, we call these. And urolithin A actually induces mitophagy, which cleans up old mitochondria, critical for your brain because your brain has more mitochondria than any other organ. It increases your insulin sensitivity, mitochondrial biogenesis, reduces inflammation. It just has so many benefits that I think are kind of fascinating. So I kind of upregulating your body's own healing system with these plant compounds, I think is really critical.
Let's talk about the gut and phytonutrients. So in functional medicine, many times we think of the 5R approach to gut healing. I have a 3-prong approach that I think of when I think about the gut and the gut-brain crosstalk. The first one is prebiotic fibers, making sure that we're getting a lot of those prebiotic fibers to come in, be metabolized by the gut microbiome, and then give us a plethora of short-chain fatty acids, things like butyrate, which can change the gut integrity, the mucin layer. It can start to change the immune dynamics in the gut and can even serve as a crosstalk mechanism to the brain to reduce inflammation, neuroinflammation.
It is absolutely the case that our nutrient intake influences our immune balance and therefore inflammation. Yet our brains and their immune state are sensitive to a wide variety of inputs. This helps explain the connection between things like chronic stress, exercise, sleep, and inflammation. For example, when our eyes and ears detect a stressor, they tell our brains to make stress hormones, which long-term may actually increase inflammation. Exercise appears to modulate inflammation through the release of specialized molecules that come from our muscles. Another area of recent exploration in scientific research concerns the effect of sleep on brain immune state and inflammation. Studies show that getting good sleep is linked to more balanced immune health and may actually help to suppress excess inflammation. Some of these pathways, I'll admit, are a little bit complex, but it's interesting to note that even hormones like melatonin may impact inflammation in the brain.
I think there's a lot of interesting things around melatonin. For example, melatonin actually is a SIRT1 agonist, meaning it binds to the sirtuin family of acetylase enzymes and actually activates sirtuins, which improves longevity in every aspect. It activates DNA repair. It inhibits NF-kappa B, which is an inflammatory friction factor, and causes the activation of P53 tumor suppressor genes to suppress cancer.
We do a whole chapter, and we will talk about, some of my favorite nootropics in the new book that's coming out, because a whole area of science called neuronutrition, meaning your brain is only 2% of your body mass, but it actually requires 20% of the nutrients, 20% of the energy, 20% of the oxygen. It's an energy hog. So I prefer people get it through my favorite brain foods, which are like avocados and blueberries. I like to call them brain berries. Broccoli is one of my favorite brain foods, olive oil. Eggs, if your diet allows. The choline in eggs is very good for cognitive health. Green leafy vegetables like kale and spinach, wild-caught salmon and sardines, those fatty fishes. Your brain is high composition of fat. Turmeric, to have a lower inflammation. Walnuts, high in vitamin E, which is neuroprotective. Dark chocolate, generally what's good for your mood. I notice it tends to be good for your mind also.
If we look at the composition of the brain and of the whole body in this case, every cell membrane has omega-3 fats. Where does inflammation start? Within the cell. And what I have seen just even clinically is that even when people supplement with omega-3s, many times they can fall low in their omega-3 levels. It's surprising. It's really surprising. So that tells me either they're not absorbing it, or they're using it, so they're metabolizing it, or they're just excreting it, or it's going into certain organ systems. And, we have to keep a pulse on that. And that's really easy to check. And omega-3s, fortunately, aren't that expensive. And then if I think of, I think a daily multivitamin, multi-mineral is important just to cover our nutrient gaps.
But if we treat our bodies and our brain well, we take care of ourselves, we eat in a healthy way, we fend off inflammation in the gut and in the brain through how we eat. Those anti-inflammatory, colorful, antioxidant-rich foods, those plant polyphenols, All of that helps to fend off neuroinflammation. And by fending off neuro or brain inflammation, we are really taming down any type of condition in the cells in our brain that could later advance to some form of cognitive disorder or more. So there are really important reasons we should be paying attention right now. It's really not related to age, it applies to every single one of us.
We need to be consuming lots and lots of extra virgin olive oil, for example. We need to have a lot of the omega-3s on board. We need the specific omega-3 called DHA, docosahexaenoic acid. Why? Because that DHA forms an incredibly important structural component of each and every brain cell, but also has some other activities. It actually acts as what we call a signaling molecule. Let me break that down a little bit. While this omega-3 is good as a raw material to build brain cells, it also does some important things otherwise. First, DHA acts in the body and in the brain as a natural anti-inflammatory. It functions as what we call a COX-2 inhibitor, meaning, it functions like certain drugs that have been developed that reduce inflammation. And why is that important? It's important because inflammation directly threatens the brain. Alzheimer's is an inflammatory disorder. We need to be consuming a low inflammation diet, and DHA is a key component of that, in addition to providing raw materials to build brain cells.
DHA, which is basically an omega-3 fatty acid from fish, usually is more in wild animals and wild plants, but not so much anymore. That it actually is what most of your brain is made of. And so it's critical for the foundational structure of your cells and your cell membranes. And it improves the connectivity, the communication between cells, reduces inflammation in the brain. So it's so critical to eat the right types of fat. And most of the time we really can't get it from our diet. The sad news is we don't need a wild diet anymore, which is where we used to get from. The fish we consume is great, but it's also full of mercury and PCBs and microplastics and who knows what not. So it's unfortunately not the safest food to eat. There are some things that you can do, like there's regeneratively raised animal fish farms where they have high levels of omega-3s and low toxins. But I think getting the right amounts of omega-3s is really critical. Second is, it seems like olive oil and is particularly good fat for many reasons. It has things like aleuropine, which it regulates, many of the longevity pathways like mTOR and others, and it improves inflammation and maybe acts as an anti-inflammatory as Advil in some studies. And then it's a great overall fat to make as a staple of your diet.
When we start thinking about broccoli sprouts and eating broccoli, that's another very powerful part of delivering. And there are studies actually in the medical literature that talk about what happens if you're eating diets that are rich in these glucosinolates or these cruciferous vegetables. What happens in your body's ability to eliminate over-the-counter drugs like acetaminophen or ibuprofen? These, as you know, are drugs that are for inflammation, pain, and over-the-counter. And it turns out that these vegetables, when they're consumed, influence then the rate at which these drugs are detoxified, and they increase their release from the body. So this might be good in some cases, and maybe other people say, well, hold on, I don't want it to be released too quickly. What I'm really saying is that these glucosinolates that come from the cruciferous vegetables are very important as part of our body's support of our detoxifying machinery. So that would be one. Number two is, I've already mentioned curcumin that is in turmeric. I think that spice, turmeric spice, has so many benefits. Literally thousands of studies have been published on turmeric. And so that's a really good one to put on the list. I've already mentioned ginger. That's a really good one. The fourth would be epigallocatechin gallate, EGCG. That is a principal phytochemical found in green tea or in all teas, but concentrated in green tea. And a couple of cups of green tea a day provides a couple hundred milligrams of ECGC, which is, again, found to be very important in neurochemistry to prevent dementia in animal models. So that would be another good one on my list. And then there's one that has gotten a lot of press lately that I think is really important. That's called quercetin. And quercetin is found in many, many different foods. If you do a little quick search, you'll say, well, it's in onions at high level. Yes, it is. It is high in the allium family of vegetables. That's true. It's also found in whole grains. But the best source of quercetin, far and away, is Tartary buckwheat. This ancient food, 4,000 years cultivated. It's one of the oldest foods known. Kind of got lost in America actually 200 years ago. But we've been really actively interested in this because the level of quercetin and other of the companion members of its family, of its phytochemical family, are 50 to 100 times higher than any other food that we know of. So this is like a supercharged source of these specific phytochemicals in the quercetin family that are involved, again, with really important roles in brain chemistry. It has been studied extensively as its anti-inflammatory effect, an effect to normalize the glial cells in our brain, the microglia, the brain's immune system.
Dr. Dave Heber's group at UCLA, they did a study many years ago. It was just a one-term study, just a very acute, short-term, where he had the participants eat a hamburger, just a plain old burger. We're not talking about grass-fed or anything like that, but just a plain old burger. And then he tracked their postprandial levels of inflammatory cytokines as well as changes in lipids. And yeah, there was that increase in inflammation that occurred after having the burger. Then he had the people come back and have that burger, but with half of an avocado. And you know what happened to the inflammation? It flatlined. There wasn't that same response. So I do think that we need to partner. If we're going to have high fat containing foods, we need to be thinking about partnering it with phytochemicals.
It's really critically important that we rein in inflammation in the body itself. When we look at all the tools that we have to make that happen, by consuming foods that are rich in bioflavonoids, polyphenols that can help us dampen down inflammation, by keeping our blood sugar in check, for example, by nurturing our gut bacteria to maintain the integrity of the gut lining, to reduce the activation of inflammation that happens when the gut lining becomes more permeable or leaky. These are all tools that we have to really bring inflammation under control. Not that inflammation is always bad, because it is not. There are times when we need inflammation. We need inflammation to take care of infections, to help us with wound healing, etc. But it's this chronic, low-grade increase in inflammation that is so devastating for the brain over time. I think many people have heard of inflammation in the context, for example, of COVID. The so-called cytokine storm was a situation in which cytokines, the transmitters of inflammation, if you will, suddenly got amplified dramatically and threatened the brain, threatened the lungs, threatened the heart, etc. That was a sudden surge of these inflammatory chemicals.
Inflammation is certainly a buzzword today, and it's likely to remain a villain for years to come. As we've said, though, there's nuance to this story. While inflammation is essential to our survival, chronic inflammation is certainly not something we want in our bodies or in our brains. The goal for most people is not to completely suppress the immune system and inflammation, but rather to create an environment in our bodies where inflammation can take place in just the right place, at just the right level, and for just the right amount of time, and not drag on indefinitely. We've heard a lot from our speakers about how we can use diet and certain nutrients to help keep unhealthy inflammation in check. But I also want to call your attention to some other lifestyle choices that have been linked to lower levels of chronic inflammation. To start, research indicates that simple movement each day is one of the most powerful tools for lowering the harmful effects of chronic inflammation. If you don't already exercise, start with something light and fun and work your way up from there. It's important that you pick something that you enjoy so you'll stick with it. You'll learn a whole lot more about exercise's effect on inflammation in episode 8. Another great strategy is getting better sleep each night. We covered this topic more in depth in episode 5, so remember, better sleep seems to support a more balanced immune system and more balanced immune function. Finally, anything we can do to lower chronic stress is a great tool to tamp down chronic inflammation. While stress hormones initially seem to quell excess immune activation, long-term exposure to stress appears to have the opposite effect. We'll learn more about this relationship in episode 11. I know stress isn't something we can quash overnight, but something as basic as a daily mindfulness practice can be a great place to start on this front. Don't forget that you have so much that you can do to help lower the damaging effects of chronic inflammation in your life and in your brain. And it can be as simple as what you put on your fork at the next meal.
Brain health matters because your brain is the control system for your entire body. It is so essential to your health. And I want you to care about it before you get some scary diagnosis related to it.
Brain health matters because everything that we feel, act, and will do in life is dependent upon the health of our brain.
I hope you've enjoyed this episode of the Better Brain Blueprint. I'm Dr. Austin Perlmutter, and I'll see you back here tomorrow for the next episode.